Hello everyone. As a quick recap, in previous lab we analyzed a bat file which enabled persistence. So every time the bat is executed, it will retrieve a Powershell script from command and control server, and finally it will execute it. Now in this lab we will review that script to understand the next steps. So let's go to our folder HackDev, Module 8, Lab 3. Okay, so this is the script file. Let's take a look. And we can notice there's a variable assignment, a letter X, and a very long line. This is still the first line. Yep, okay. So this is the first line, assigning another letter Y and calling PowerShell.exe. Okay, let's make some modifications here so we can try to deobfuscate it. But first, let's make a copy of this just in case. Okay, so let's split this in 2 lines, 3 lines actually. Great. Okay, so what is doing the first line? The first line is assigning a very long string to the variable X. Then we assign to the variable Y, X replacing every occurrence of this substring with an empty string, and finally executing PowerShell with the parameter encoded command and this variable. Encoded command, what it does is takes as an input a base64 string, and it decodes it and executes it. So this is simply a way to hide PowerShell commands. So what we are going to do now is, okay, we're going to use the fact that they are already doing the decoding, the replacement of that substring. So now we're going to create another variable, PowerShell code, which is going to be the base64 decoding of this. So we have to call system convert base64 string, and we supply the variable. Okay, now from base64 string it returns an array of bytes, so we still need to decode that as a string. So there's another step here, system text encoding Unicode, because encoded command requires that string to be Unicode. Get string PWS code. Great. So now we have the actual string. Now let's write that to a file. And that file will be malicious.ps1. Let's comment this line so it does not execute code. It simply writes it to another file. And yep, now let's run our script. We have to open our command prompt. We navigate to our folder HackDev, Module 8, Lab 3, and we execute it as PowerShell execution policy bypass file next stage.ps1, and that's it. Now we can list the contents, and notice there's a malicious.ps1. So let's take a look at it. Right, so now we can notice there are some function definitions with very weird looking variables, long strings as well, some test path, we have some exit command, another functions, another very long lines, and finally this other functions. Okay, so let's try to first understand what could be doing this script. Let's go back to the beginning. Okay, so these are function definitions, so we can skip them by now. The first important part is it's right here, is doing a test path, but with a obfuscated string. It's using this function and giving 5 parameters, 3 integers, a long string, and another integer. So let's go to the definition of that function. Oh, here it is. Right. So now what is going on here? This function is receiving 3 integer parameters, a string parameter, and another integer. It's defining an empty string, which is going to be the result. It's taken from the string parameter a substring defined by some of the other parameters. We can say for sure this function is not dangerous, it's simply operating over strings. So in this case we can use our tool NeZa, and we execute it as this: Powershell execution policy bypass file. We have to specify the path, which is in hackdev tools. That's it. We have to provide a file path, which is malicious. We want the verbose output, and we do not want to execute the result. And here comes the useful part. We have to specify dynamic deobfuscation. Okay, so now we need to provide a function name. Let's say this one. And the tool is has identified this is the code of the function. We have to confirm we want to execute that function because we are going to resolve all of this obfuscated strings dynamically. So we confirm. And yep, now it's executing. These are the statements that are being executed, and here we have the result of each of those statements. So this is very helpful because we do not need to manually create another PowerShell script, copy the definition, copy the statement that we want to evaluate, and then replacing the result in the original script. Okay, so now it's done. Here we have a preview of the deobfuscated file. This is the original file. We can see here it's still discalls, but we can open malicious.deobfuscated, and this file has the strings deobfuscated. So here we didn't know what was this, but now we can clearly see that this is a string load extension, and this is env local app data. Right, so we can continue with this process using another non-dangerous functions. Let's try to find another one. Okay, so this is the one we already used. There are no more occurrences, so we can safely delete it. And here we have other two functions. This is simply calling substring using the parameters, and the same as this one. So we can execute our tool using these two functions. So let's do that. But now we are going to use as an input the deobfuscated version. So deobfuscated, and we want to provide another parameter, overwrite file. So it does not create a malicious deobfuscated. It overwrites on this file. So let's hit enter and provide the function name. Yes, we are sure we want to execute that code. And we wait for it. In the meantime, we can still take a look at the original malicious file. Oh, seems like it's done. We say yes, we want to overwrite the file, and that's it. We have to reload it, and now we have some other set of strings deobfuscated. There are no more occurrences of this function. We can delete it, and now repeat the process with this other function. We confirm and wait for the tool to finish. Okay, let's take a look in the meantime to the other functions and the flow in general. Okay, so we have these functions. Here we have the test path. Now it's clear what it's trying to do. It's testing a registry key, software, Microsoft Windows, current version, app paths, Chrome. So this is a way to test if Chrome is installed in the current machine. So in case it is not installed, we simply exit the script. Okay, so seems like a target attack for the Chrome browser. Okay, so it does a test, then defines this array with two paths for Chrome, defines another function, and goes with for each Okay, let's confirm this modification. Okay, so now these two functions are good. Great, we'll remove them and continue exploring. Okay, so this are some paths for Chrome, so we can rename this variable as Chrome paths. Oops, sorry. Chrome paths. Replace it. Okay, we iterate in each one of them, test if that exists, and save it in another variable. So this is like the real Chrome path. Great. Okay, so far it's checking if there is a path to Chrome, if it's installed. Then we have these lines with very long strings. Let's fix this and checking this. So now the lines are in a single line, and we have to use this bar to navigate. Okay, so here's defining some arrays using pairs of strings. We have one string is using another string, and okay, basically doing that, calling some of the functions defined before. And finally calling this function. So this is calling again the function CW, which is using local app data and so on. Okay, so maybe we should go back to the first functions and try to see if we can use our tool to deobfuscate more this script. For this function, it's defining a long string. What is really interesting is that it's using this command IEX, which is an alias for invoke expression used to execute code, and it's only separated by a semicolon, so we can split this actually in two lines so we can see more clear what's going on. Okay, so it's calling IEX, invoke expression, and the result of replacing in this string this exact substring with the empty string, so it's removing all the occurrences of this. Then it's doing a base64 decode and retrieving a string from that. Okay, so it executes that code. We cannot safely use our tool here because we are not sure if this is actually a malicious code. So let's create another file and copy these two parts. And save them as playground.ps1. Okay, so we can try to print what is the real code. Okay, so this first part does not seem to be useful. It's simply checking if this variable is equal to null. It's not actually used anywhere else, so it's most likely to be null, so we are going to remove it. And this AND also is not useful anymore. And here is the definition of the string. Okay, we can also remove this parenthesis. This is called to out null. Great. Okay, so next step is doing the replace. So we are going to create a variable pws code and copy all of this. Right, we'll remove the parentheses, and here it should be the pws code. Finally, we define this as if we take this part, okay, and well, we can actually define this as pws code and simply write it to the screen. pws code. Okay, now let's go back to our terminal and execute our playground. Execution policy bypass file playground. And that's it. That's the code. It's being executed. We can copy it and replace it in our deobfuscated version. We can remove this and paste it like this. So we notice that it is also a base64 decode, but this time is using a parameter, and it's returning that result. So this function is actually non-dangerous because it's only doing operations on strings and doing some base64 decoding.